In the 20th century, someone at IKEA believed in the flat-pack, ready-to-assemble furniture, which changed the furniture industry. The idea was simple: standardize, modularize, mass-produce. No lead time. Customers embraced the freedom to buy when they wanted to. In the 20th century, even before IKEA, few companies tried to do the same for house construction. One built around 70,000 high-quality standardized kit homes with low labor costs, but failed. The reason was the waning demand for standardized houses. For some reason, most of the homes are custom designed. Demand for custom designed houses is here to stay. Today's big construction challenge is the high labor costs arising from low productivity, compounded by surging demand for the flexibility offered by traditional methods to build custom homes. Confidence in the sector is dropping fast. How can we blame the builders for low productivity if we continue demanding the time-consuming, labor-intensive efforts required for traditional construction? None of the alternative solutions really cut it. Until now. Welcome to Sonmill. Welcome to builder-friendly construction. What if solid walls could be built using lightweight structural panels instead of blocks, but still allow custom lengths, opening sizes, and locations that suit your every need? Imagine having the power to build custom-designed, next-generation, traditional solid walls using ready-to-build modules. At Sonmill, we integrated and re-engineered the time-tested materials into modules for better performance, simple construction, and mass production. By standardizing panels, we found a better way to transfer the on-site work to the factory and pass it on to machines. We do the heavy lifting at the factory to build the modules a builder needs. By making the modules suitable for simple construction, customers can save on labor costs or take on the labor themselves. What sets us apart from other systems? There are two primary methods for building houses: on-site construction and off-site construction, with a significant gap between the two approaches. For example, for stud walls with on-site construction, builders typically need to purchase approximately 300 studs, which can be delivered the next day. Each stud weighs around 5 kilograms, and with skilled labor, they can be assembled on site, a slower traditional construction. In contrast, off-site construction involves the delivery of 30 pre-built panels. These panels are bespoke, so they typically need to be ordered 10 weeks in advance, as the labor-intensive assembly is done in a warehouse. A typical panel weighs about 150 kilograms, and it is a faster construction, but usually requires a crane. We are introducing pre-built wall modules. The builder can purchase modules like they purchase the studs. One typical module weighs about 50 kilograms, offering a relatively faster construction without skilled labor and cranes. We take a balanced approach. At Sonmill, we believe that we are the first to introduce the ready-to-build module-based system. These panels come in a perfect size and perfect weight and have no lead time for builder-friendly construction. We have integrated some of the best materials and technology from other forms of construction to improve performance and simplify module-based construction. Here is how structural, insulation, and architectural finishing materials are combined in other construction systems. In a timber stud wall, hundreds of timber studs mainly act as structural elements and are put together with screws and nails. Then, insulation is fixed between the studs. Finally, the OSB boards and plasterboards for architectural finishes are fixed. In a traditional load-bearing block wall, the block serves as the structural material and effectively provides the wall with insulation properties and better thermal mass. Hundreds of blocks are joined by mortar, a cement-based adhesive. Later, boards for architectural finishes, commonly plasterboards, are fixed with adhesives. In insulated concrete formwork, ICF construction, insulation made with polystyrene is first assembled. Then reinforcement is installed and the cavity is filled with concrete, a structural material. ICF block acts as permanent formwork for concrete. Finally, boards for architectural finishes are fixed with screws. One successful system in Australia uses fibre cement boards, which are bespoke panels. However, these boards are not designed to take any loads, while reinforced concrete is designed to take all loads. SIP wall is an off-site construction method. Bespoke panels are made by gluing OSB boards and insulating material together under pressure at the factory. OSB boards will act as the primary load-carrying structural element since the buckling is resisted by bonding with insulation material. At the site, panels are jointed with a spline, and boards for architectural finishes are fixed with screws. We've re-engineered the timber stud wall. Several horizontal members such as the head track, bottom track and noggins are omitted from our system. The timber stud is replaced with a fire-rated hollow stud, with an option to reinforce it with optimized light-gauge steel studs. This design will reduce thermal and acoustic bridging between the opposing faces. These studs are bonded with boards for architectural finishes. They are modularized and made into 14 standard panels or modules. We replaced the plasterboards and boards for architectural finishes commonly found in other forms of construction with fibre cement boards, a premium material used as tile backer boards in bathrooms where you won't take a chance with plasterboard. This material is also used in cladding and roofing and is fire and moisture resistant. You can skim coat directly on it for the painting. These units will also act as permanent formwork for insulation materials. Customers can choose the infill insulation material that can be optimized. In addition to insulation properties, it has to have nominal structural strength and be ideally pumpable with a machine. This will reduce the labour work at the site, enhance the structural integrity of the whole house system, and provide an inherently airtight structure. Once the cavity is filled with insulation, the wall resembles a traditional aircrete block wall. We do not call these units the permanent formwork system because modules are engineered to form the primary load-bearing structural system, which also acts as permanent formwork. We call them Stud Integrated Modular Walls, or SIM walls. This will require less labour than other traditional on-site construction methods. However, the overall cost may be similar because of the premium materials used in SIM walls. Would you choose to spend more on material or labour? What are the benefits? This is more about freedom than cost. You have more freedom in what performance you want, how fast you can build, and who you choose to build with. Firstly, the freedom in performance. This system is meticulously designed for maximum structural, thermal and acoustic performance, fire and moisture resistance, and an inherently airtight structure. In addition to performance, you will have more freedom in cladding, interior finishes, and safety. Cladding. You can build a separate traditional brick wall cladding with your choice of insulation, or build with our insulation pre-fitted external wall with the higher amount of insulation you need. Even then, you can have any brick slips directly fixed on the outer face of the wall, or lightweight rain screen cladding fixed to the external face. Finishes. You don't need plastering and plasterboards on the walls. You will have the freedom to screw into the wall and hang the art or art mode smart TV. You will have freedom to tile the living room. Safety. You will still be free to avoid combustible materials like timber and petroleum products like polystyrene and polyurethane in the structural walls. By using premium materials, you can build highly energy efficient houses up to and beyond passive standard ones designed for sustainable construction. Secondly, the freedom in program. Order the materials the day before you want them on site, no lead time. Compared to traditional on-site construction, you have 3 options to build with: 1,000 blocks, 300 studs, or 100 modules. Yes, it's faster on-site construction. This empowers builders to construct 2 houses in the time it typically takes to build 1. Third and finally, it is the freedom in people. The tools and lightweight products of this approach make it possible for anyone to build. If you can plumb it, you can build it. A crane-free installation with lightweight units. The process is simple. Step 1. Place the panels. Place the standard wall units at 400mm spacing. Standard props and simple brackets will help align and plumb the wall panels, and corner wall units go to the corner. Here the first electrical fittings need to be done. This shows that insulation pre-fitted external wall panels are installed. The standard opening for the window comes with 4 standard components. Step 2. Fix the boards. The next step is to fix the pre-cut boards, which provides the much required freedom to achieve the custom length requirements at the site by cutting a few boards. About 40% of panels come as pre-cut boards. This helps reduce transportation costs and makes service installation easier. Step 3. Fill the wall cavity with insulation material. Foamed concrete is one option. It is a cement mixture with air bubbles that provide good insulation properties. The end product is similar to aircrete blocks found in traditional construction. It is self-compacting, lightweight, and used in the housing industry to insulate roofs, floors, etc. This construction method blends well with traditional floor construction. Hempcrete is another option filler material. It provides good insulation, reasonable strength and fire resistance, and it is breathable and sustainable. Above all, its carbon negative nature makes it ideal for net zero construction. Gable wall units are made in standard slopes and lengths. Again, the lengths can be adjusted on site by cutting the boards. How does the system work? We have optimized the structural system by integrating premium materials in better configurations and the right amounts. For example, reinforcement bars have no load carrying capacity on their own, but can carry half the load in a high-rise building when buckling is restricted through engineering. Our studs are fabricated with fibre cement boards and fire-rated adhesive, a patent-pending invention. We engineer the boards so that buckling is restricted. Like timber studs and metal studs, they can take loads. This study enables the fabrication of modules. When required, these studs can be reinforced with light-gauge steel studs. The studs are kept apart, reducing bridging and improving the acoustic and thermal insulation. When a stud is reinforced with light-gauge steel studs, it will act as a composite stud. By bonding the studs with boards for architectural finishes, modules are optimized to take loads. Structural load carrying capacity is further increased with insulation material filled into the cavity, offering a far better structural system than a traditional block wall. Since boards and insulation are designed to take loads, minimal steel will be needed for a typical 2-story house construction. Ultimately, this system offers maximum material efficiency. Why now? Advancements in the adhesive industry made this system possible. Time-tested, very strong, flexible adhesives are used in housing construction for various purposes. This is how we started testing the adhesives. The results were exceptional. We are driving solutions that can address the industry's skills shortage, contribute to solving the housing shortage, and transform how we build better and faster. So, what makes this solution so revolutionary? The idea is simple: standardize, modularize, mass produce. We use proven materials. Everyone can benefit from mass production by standardizing modules, including low-cost advantages due to automation, higher efficiency, prompt distribution, and transport. These modules are a perfect fit for automated production lines. At Sonmill, we don't do off-site construction with bespoke panels. Instead, we bet on mathematics and mass production to meet the needs of the everyday builder. Change in the construction industry is long overdue. Now is the time to leverage novel technical advancements and define a new era where standardization meets customization. The moment has come to empower the ordinary builder with the products and innovations to transform an industry. Join this great leap forward and be part of the next generation house construction. The mill is open. Sonmill. Build with freedom.